Today we are going through chapter 13, Redox Reaction. Alright, let's go. So next. So basically there are four ways to determine if a reaction is a redox reaction. Okay, so the first way will be using oxygen atoms. The second way will be using hydrogen atoms. The third way using electrons. And the last one using oxidation states or oxidation number. So just take note that these four methods you are supposed to know, very important. So make sure you highlight them. Especially number 3 and number 4, oxidation state and electrons, because sometimes the question will actually force the students to use the oxidation number or electrons to determine if a reaction is a redox reaction. So later we'll give you some example, then you will understand better. First, let's look at using oxygen atoms. For example, this equation, 2 hydrogen gas react with oxygen gas gives you 2 water. So if you see carefully, right, hydrogen gas actually gain 1 oxygen atom to get H2O. So you will say H2 gain oxygen atoms to form H2O. Thus, hydrogen gas is oxidized. So meaning if you gain oxygen atoms, right, means you're oxidized. Gain oxygen atoms means oxidized. The next one, O2, right, become H2O. So if hydrogen gas is oxidized, means oxygen gas will be reduced. So how you write the statement? O2 will lose oxygen atoms to form H2O. Thus, oxygen gas is reduced. And then one more thing to take note is that for every reaction, right, reduction and oxidation will always take place together in the reaction. So meaning if one of the reactant is oxidized, the other reactant will be reduced. They always come in a pair. Next, let's look at hydrogen atoms. How you use hydrogen atoms to determine a redox reaction. Let's say you have this equation, N2 plus 3H2 give you 2 ammonia. So this is your famous Haber process. So let's look at N2. If you realize, right, N2 actually, after the reaction, it actually gains some hydrogen atoms. So if you gain hydrogen atoms, you are reduced. So N2 gain hydrogen atoms to form NH3. Thus, N2 is reduced. So next, what about hydrogen gas? Hydrogen gas, right, after the reaction, it will be oxidized. Why? Because N2 will lose hydrogen atoms to form NH3. Thus, N2 is oxidized. So you realize that it is actually not very clear. H2 to H3. So an easy way to see is what? If one of the reactant is reduced, the other reactant will be oxidized. So same thing again, oxidation and reaction always take place together in the reaction. So far we went through oxygen atoms and hydrogen atoms. The third method now, using electrons. Let's look at this reaction. Iron react with chlorine gas give you iron 3 chloride. So let's look at the oxidation process. Iron, right, if you realize, iron will become iron 3 plus. So I write out a separate half ionic equation. So this is the oxidation. Iron solid become iron 3 plus plus 3 electron. So if you realize, right, it actually loses what? It loses electron. Initially, electrons is inside the iron metal. After that, it becomes iron 3 plus ion and 3 electrons. So the statement, how you going to write? Iron loses electron to form iron 3 plus. Thus, iron is oxidized. So meaning when you lose electrons, you are oxidized. Next one, chlorine. Cl2, right, will become Cl minus. So if you write the half ionic equation, Cl2 will gain 2 electrons to give you 2 Cl minus. So you realize that the charge on both sides of the equation must still remain the same. The left hand side is 2 minus, the right side is 2 minus as well. So if you gain electrons, you are reduced. Cl2 gain electrons to form Cl minus, thus Cl2 is reduced. Alright? So this is the same thing. It always takes place together. Alright, the last one, which is the most important method. But before that, you have to learn some rules before you can use oxidation number to determine a redox reaction. The first rule. So this is important, so that's why it's highlighted for you. Rule 1, oxidation state of the element will be 0. So a hint, right, to remember this is what? You can always assume, right, oxidation state, right, is very similar to its charge. So let's look at some example. Example what? Copper. Copper element. Is there any charge here? There's nothing, so it's like 0. So the oxidation number of copper element is 0. Next one, Cl2. Okay, Cl2, is there any charge at here? There's no charge, right? So the oxidation state will be 0 as well. Okay. Next one, aluminium metal. There's no charge, so it's just 0. Okay. So the next one, rule number 2, oxidation state of an ion will be its charge. What does this mean? Same thing. So when writing oxidation state or number, right, the plus and minus must come before the number. Okay, what do you mean? Let's look at one example. Oxidation number of what? Cu2 plus is plus 2. Can you see? The charge is what? 2 plus. So the oxidation state will be plus 2. It's like opposite. The charge will be number first, then the plus minus. But for oxidation state, right, will be plus minus first, then the number. Okay. Next one, Cl minus. Okay, chloride ion. So the charge is -1. So the oxidation number will be -1 here. Next one, aluminium. Okay, aluminium 3 plus. The charge is 3 plus. So the oxidation number will be +3. Okay, so the charge is very similar to the oxidation number. Last example, O2 minus, your oxide ion. Okay, so the charge is 2 minus. The oxidation number will be -2. Okay, moving on. Rule number 3 now. Oxidation state of a compound will be 0. So this one is to help you. The sum of the oxidation number of individual ion, right, must add up to 0. So what does this mean? Okay, before that, one more rule for you. Only write oxidation number for each element, not the total oxidation number for the element. Okay, this one might sound a bit confusing. I'll use an example to elaborate. Let's say MgCl2. So if you see the whole thing, right, this is a compound. Is there any charge here? There's no charge. So it means what? Magnesium plus 2 chloride add up must be 0. Okay, so if you use the periodic table, right, okay, Mg will be what? +2 because it's group 2. Okay, so the charge is +2, so the oxidation number will also be +2. Next one, chloride ion is group 7, so the charge is -1, so the oxidation number also -1. So if you add up, right, +2 plus what? -1, but -1 you must times 2 because there are 2 chloride, so add up will be 0. So it makes sense. Okay, the whole compound must be 0 when you add up the individual ions. One more example, NaOH. Okay, so sodium group 1, so it's +1, so the oxidation number also +1. Oxygen is group 6, so the charge is 2 minus, the oxidation number also -2. Hydrogen is +1. Okay, then if you add up the total, it will be 0. Okay, so same thing. So the rule number 3, oxidation state of a compound will be 0. So that is how you apply it. Okay, moving on. The last rule. Okay, rule number 4. In a polyatomic ion, right, the sum of the oxidation number of individual ions must add up to its charge. Okay, what does this mean? Only write the oxidation number for each element, not the oxidation number for the element itself. Okay, and then before that, there are a few rules. Hydrogen is always +1, which you show it just now in the previous example. Okay, except for metal hydride, it is -1. Okay, so this is the only exception case. So once in a while you will see this one, so just watch out for this one. But most of the time, hydrogen will be +1. Next one, oxide ion, okay, is always -2, except for what? Hydrogen peroxide. So this is the only exception, right, whereby your oxygen atom, right, it's -1, not -2. But most of the time it will be -2. Okay, like maybe 95 or 99% of the time. Let's look at one example. Let's say PO43-. This is what? A polyatomic ion. Okay, so this ion, right, is made out of what? 2 atoms. So the overall charge is 3-. So it means what? Phosphorus plus 4 oxygen, right, must be 3- in the end. Okay, so you realize I put just -2. Okay, some student will say 1 oxygen is -2, but 4 oxygen is -8. But realize this is the rule. Only write oxidation number for each element. Okay, not the total oxidation number for the element. So you just write -2. You don't put -8, just for 1 oxygen atom. Okay, the oxidation number is only for 1 atom. Okay, 1 element. And then next, if you realize this one, you can let P be X. The oxidation number for phosphorus, right, let it be X. So X plus 4 oxygen now, each oxygen is -2 equals to -3. So you just rearrange, you'll figure out your X is what? +5. Okay, phosphorus is group 5, so kind of makes sense. Got it? Okay, so individual atoms or individual ions add up must be equals to the overall charge here, which is -3. One more example, SO4 2 minus. Okay, so same thing, we always start from oxygen. Oxygen is -2, but there are 4 of it, so you have to watch out. Everything add up with the sulfur must be -2. So let's look at the working. X is for sulfur, okay, so you're supposed to figure out X plus what? 4 oxygen, so it's 4 times -2 equals to -2 in the end. Overall is -2. So if you rearrange, X will be +6. So kind of makes sense as well, because sulfur is group 6. Alright, so that's how you do it, okay? So this one, just take note. Oxygen, you must put -2, but when you calculate, you must be -8, okay? So there's a difference, be careful. Alright, one more example for oxidation number. So this one is the full equation. This is most likely the type of question that you'll get in the exam. They'll just give you one full equation. Your job, right, is to write down the oxidation number for every single element. Okay, let's see how we do it. Sodium here is an element. So elements, remember rule number 1, the oxidation state will be 0. Okay, so there's no charge here, so it's 0. Okay, FeCl2. So we can start with Cl first. Cl is group 7, so it's -1, but total is -2. Overall must be 0. So what do you think iron must be to balance out the whole thing to become 0? Here is -2, so here must be +2. Okay, or you can do reverse cross, Fe2 plus, the charge is +2. Same thing, sodium is group 1 +1, so chloride must be -1 to balance out. Okay, and then iron, this is the element itself, so it's just 0. Okay, next, so you can write down, so which element actually changes? So look at iron. Iron from +2, right, it will get reduced to become 0. So if there's a decrease in number, means you are reduced. Okay, then which element? Okay, so we write down the statement first. So this is the way you write it in a very clear format. Okay, like a template for you. Okay, FeCl2 is what? This whole element is reduced. Okay, as what? The oxidation number of what? Of iron. Okay, so oxidation number always refer to the element. So you have to say oxidation number of iron or oxidation number of chloride. You cannot say oxidation number of FeCl2. A compound does not have an oxidation number. It only exists for an element. Okay, as the oxidation number of iron decreases what? From +2 in where? In FeCl2 to 0 in Fe. So it's very clear. From what number to what number? From where to where? Got it? Okay, so I repeat again. FeCl2 is reduced. Okay, some students will argue that, saying that only Fe is reduced, but nothing to do with chloride. But for our format, right, usually when you write, we'll write the whole compound. Okay, the whole compound. Okay, FeCl2 is reduced because what? The oxidation number of iron decreases from what? +2 in FeCl2 to 0 in Fe. Okay, so it's very clear, this kind of format. Okay, let's look at the next one. Who is oxidized? Sodium. From 0 to +1. Okay, so the statement, Na, okay, this is the reactant, so just write Na. So you take note, we don't have to write the 2 in front. The 2 in front is just for more concept. So as far as redox is concerned, you do not have to write the 2 here. Okay, so Na is oxidized as what? The oxidation number of what? Which element? Sodium. Okay, increases from 0 in Na to +1 in NaCl. Okay, in NaCl. Okay, so be careful. So this one, just a reminder, this must always be the formula of the reactant. The reactant can be an element, it can be a compound, it doesn't matter, as long as you follow the reactant formula. Okay, it must be the reactant, so watch out. And then this one, I emphasized just now already, the oxidation number of what? Of the element, it must be the element. Okay, no other way, must be the element. Same thing as sodium. Okay, with that, let's move on to the second example. This one I'll give 3 examples in total so that you can really understand what is going on, because this is most of the time what you're going to do in the exam. Example number 2, okay, new equation. Okay, Cl2 plus FeBr2 give you FeCl2 plus bromine. Okay, so if you realize what is this one is actually your what? Halogen displacement. Okay, chlorine is more reactive than bromine, so you displace bromine and then form iron chloride. Okay, then bromine will be displaced out. Let's look at the oxidation number. This one, element, so it will be 0. Okay, next, okay, your bromine, group 7, so it's what? -1. And then iron must balance out. There's -2 here in total, so it must be plus 2. Next one, this one, chlorine will be minus 1 as well. And then to balance out the minus 2, so iron must be plus 2. And then bromine gas here in this itself is 0 because it's an element. Alright, let's look at which one. Which one actually oxidize or which one reduce? Okay, chlorine from 0 all the way to minus 1. So it's been reduced. Okay, so if the number from 0 to minus 1, it decreases. So it's been reduced. Okay, so how you write the statement? Same thing. Cl2 is reduced. Okay, it's reduced as what? The oxidation number of what? Chlorine, okay, decreases from what? 0 in Cl2 to minus 1 in FeCl2. Okay, so it decreases from 0 to minus 1. Okay, then with that, which one actually oxidize? Is it Fe? Fe is plus 2 to plus 2, so there's no change. Okay, so it's not Fe. Okay, so it must be Br. Br from minus 1 to 0. Okay, so let's look at the statement. So same thing, this whole compound FeBr2 is oxidized. Okay, oxidized because what? The oxidation number of bromine increases from minus 1 in FeBr2 to 0 in Br2. Okay, so just grab the numbers accordingly, then just figure out the template itself. Okay, next one, example 3. Let's take a look at this equation. Okay, Fe2O3 plus 3CO give you 2 iron plus 2 CO2. So if you know what is this going on, this one is your what? This is basically your third equation in your blast furnace, extraction of iron. Okay, so let's write out the oxidation number. Oxygen, we always start from oxygen first because oxygen most of the time it will remain as minus 2. Okay, so it's minus 2. If you reverse cross, iron must be what? Plus 3. Okay, so balance out, so everything add up will become 0. Okay, and then CO, let's look at oxygen. Oxygen is minus 2, so carbon must be what to balance out the whole thing? Plus 2. Okay, the 3 in front, right, is not important, it's just for balancing equation. Okay, so just ignore it. Next, iron, element, so it's just 0. Okay, CO2, oxygen is always minus 2 in a compound, then this minus 4, so carbon must be what to balance out? Plus 4. Alright, so let's take a look who oxidize or who reduce. Okay, in this case, your iron from plus 3, you decrease to what? 0. So if you decrease in oxidation number means you are reduced. Okay, so the statement Fe2O3 is reduced as what? The oxidation number of iron, okay, iron element decreases from plus 3 in Fe2O3 to 0 in Fe. Okay, 0 in Fe. You realize that I didn't write the 2 in front here. Okay, because it's not important, because I say just now. Okay, it's only important for balancing equation. For redox, you can ignore the 2 in front. Okay, next one. So if Fe2O3 is reduced, so CO must be oxidized. But which element? Is it oxygen or carbon? Oxygen from minus 2 to minus 2, no change. So oxygen is not important here. It's carbon from plus 2 to plus 4. Okay, so the equation, the template, okay, CO is oxidized as what? The oxidation number of carbon increases from plus 2 in CO to plus 4 in CO2. Okay, so just take note of this one. Alright, just one thing to take note, okay, as you get familiar with this topic, right, as you write the oxidation number for each element, right, your speed for writing all this oxidation number, right, should be as fast as how you balance the equation. Okay, it shouldn't take too long. Okay, alright, so hint for you for oxidation number, always use this template when answering question. So I write down the template for you already, so you already see how we use it just now. So this is the reactant. Reactant is always reduced as the oxidation number of which element decreases, because it's reduced, so it's decreased. Okay, oxidation number must decrease from what number in which reactant to what number in which product. Okay, the same thing, this for oxidation. Reactant is oxidized as the oxidation number of which element increases from what number in which reactant to what number in which product. Okay, means from where to where. Okay, so this one is like a template. Going through the 4 different ways to determine a redox reaction. Okay, now we need to learn what is the definition of oxidizing and reducing agent. So first, oxidizing agent is a substance that oxidizes a substance. Okay, so a clue is what? Oxidizing agent, right? Meaning OA itself will actually be reduced. So he himself will reduce. He will oxidize another substance. Another thing, reducing agent, right, is a substance that reduces a substance. Meaning, Ra itself, right, will actually oxidize. So let's look at some example first. Example number 1. So this one is the equation just now we went through. So we already mentioned that what Fe2O3 is actually reduced to Fe. So if Fe2O3 reduced, so he's a OA. Okay, so because he himself will get reduced, but Fe2O3 will oxidize CO. Okay, so you realize CO here is actually oxidized into CO2. So if Fe2O3 is a OA, CO will be a Ra, reducing agent. Okay, because he himself oxidized, but CO actually reduce Fe2O3 to Fe. Okay, so I repeat again, easy way to remember is what? The substance that actually reduces is a OA. The substance that actually oxidizes is a Ra. Okay, let's look at one more example. Alright, so this one, Cl2 plus FeBr2 give you FeCl2 plus Br2. So in this case, we saw that Cl2 actually reduces. Okay, so if Cl2 reduces, he must be a OA. Okay, the opposite. And if FeBr2 oxidize, he must be a Ra. That's all. So just always remember it's opposite. Whoever reduces is a OA. Whoever oxidizes is a Ra. Opposite. Okay. Alright, so let's look at some common example of oxidizing agent and reducing agent that you need to memorize for your exam. So oxidizing agent, there are two examples which you need to memorize. The first one is acidified potassium manganate 7. Okay, so if there's a reaction going on, it will change from purple to colorless. Okay, purple to colorless. The reason why it must be acidified because so that it will start behaving like an oxidizing agent. Acidified actually means potassium manganate 7 solution, right? It's mixed with any acid. Usually it's nitric acid. Okay. Next one, acidified potassium dichromate 6. Okay, is also an oxidizing agent. It will change from orange to green. Okay, so these two you have to memorize. Most of the time it will be this one, acidified potassium manganate 7 for your exam. So just watch out for the colors. Okay, reducing agent, the most common one that you need to memorize is potassium iodide. Okay, so it's Ra, reducing agent. Okay, if there's a reaction going on, it will change from colorless to brown. Okay. Okay, so this is the one that I mentioned just now. Okay, acidified potassium manganate 7. It will change from purple to colorless. Okay, so take note, it will only change color when it's added to a reducing agent. So meaning if you add acidified potassium manganate 7 into an unknown solution and it changes color from purple to colorless. So what does it tell you? It tells you that the unknown solution must be a reducing agent. Okay, this one same thing as well, acidified potassium manganate 6. Okay, so it only changed color when added to a reducing agent. So if you add potassium manganate 6 into a unknown solution and it changes from orange to green, so it shows that the unknown solution is a reducing agent. Okay, because potassium dichromate 6 is a OA, so the other unknown solution must be a Ra, reducing agent. Okay. Next, okay, so this is your reducing agent, which is your potassium iodide, colorless to brown. So same thing. So if you add potassium iodide into a unknown solution, which is an oxidizing agent, it will change from colorless to brown. Okay, unless the unknown solution is oxidizing agent. Okay, if it's just a neutral solution, it will just remain colorless. Okay, no visible change. All right. Next, this one will be important for answering MCQ. So some common reactions that are not redox reaction, okay, which students are supposed to memorize. First one is your thermal decomposition. Okay, so for example, calcium carbonate give you calcium oxide plus CO2. So this one, if you are aware, this is actually the fourth equation in the blast furnace, extraction of iron. Okay, so decomposition of thermal. So basically means that you're using heat to decompose your calcium carbonate, your limestone, to give you calcium oxide plus CO2. So none of the element actually changes in their oxidation state. So let's look at one by one. Okay, oxygen is -2, okay, group 6, and then calcium is group 2, so it's +2. So if you work backwards, okay, everything add up must be 0. So your carbon will be plus 4. Let's do the same thing for calcium oxide. Oxygen is always -2, so calcium must be what to balance out? +2. Alright, move on. CO2, oxygen is -2, 2 of it is -4. So carbon must be what? Must be +4 to balance out everything. Okay, so if you see carefully, calcium is +2, +2, no change. Carbon, +4, 2 + 4, no change as well. Oxygen, -2 to -2, no change as well. So that's why thermal decomposition is not a redox reaction. Okay, so for the exam, you all can just memorize thermal decomposition. Okay, basically using heat. Does not really have oxygen gas. Next example will be your neutralization. Okay, so your typical, okay, alkaline, sodium hydroxide, react with acid, nitric acid to give you sodium nitrate and H2O. So let's look at the oxidation number one by one. Oxygen is always -2. Okay, then hydrogen is +1. Okay, sodium ion will be +1, so you add up will be 0. Okay, what about nitric acid? Oxygen is -2, hydrogen is +1. Okay, so you work backwards, nitrogen will be +5. Same thing for here. Oxygen is -2, sodium group 1, so it's +1. Nitrogen, if you work backwards, will be +5. And the last one, water. Oxygen is -2, hydrogen is +1, so everything add up will be 0. So same thing, let's compare again. Sodium +1 to sodium +1, no change. Oxygen -2 to -2, no change. Either if you compare here also can, it's the same thing. It will be -2, no change. Hydrogen is +1. After that here, it's still +1. Okay, and yeah, basically +1, +1. Everything remains the same. Okay, so neutralization is not a redox reaction. Okay, so this one I mentioned just now. Sometimes MCQ will ask students to identify which equation is not a redox reaction. So thermal decomposition, neutralization. Okay, one more example. Okay, so precipitation. Precipitation is also not a redox reaction. So let's look at a typical example. Sodium chloride plus lead-2 nitrate give you sodium nitrate and lead chloride. Okay, so let's and then so here's the one, solid. Okay, precipitate, insoluble salt. Okay, so let's look at the oxidation number for each of them. Sodium chloride, chloride is -1, sodium is +1. Okay, here if you see lead-2 nitrate, so there's a polyatomic ion inside, so it's a bit confusing. So a smart way is what? To split them up into their individual ions. Okay, so if you reverse cross, Pb will be 2+, nitrate will be minus. Okay, so Pb, the charge is +2, so the oxidation state will also be +2. Okay, NO3 minus here, oxygen is -2, so everything add up must be -1. So if you work backwards, nitrogen should be +5. Then you can transfer it back up. Okay, +2, +5, and -2. Let's look at sodium nitrate. Sodium nitrate. Okay, nitrate and oxygen is -2, sodium is +1. So if you work backwards, nitrogen should be +5. Okay, and then lead chloride. Chloride is -1. Then lead must be +2 to balance out everything. So let's compare. Sodium here is +1. Here is +1 as well, so no change. Chloride -1. Here is -1 as well, so no change. Lead is Pb is +2. Here is +2 as well, no change. Then nitrogen is +5. Here is nitrogen is +5, no change. And then oxygen is -2. Here is still -2. So none of the element actually increase or decrease in their oxidation state. So that's why precipitation is not a redox reaction. Okay. All right. Come to the final slide, summary table. So oxygen atom, hydrogen atom, electron, and oxidation state. So let's look at oxidation atom, oxygen atoms, and oxidation state. So if these two increase, right, you're oxidized. Okay, increase is oxidized. If your oxygen atom decrease or your oxidation state decrease, you have been reduced. Okay, what about hydrogen atoms and electrons? If you have a decrease in your hydrogen atoms or electrons, means you are oxidized. But you have an increase in hydrogen atoms and increase in electron, you are considered reduced or reduction. Okay, so that's all for this. Okay, so this is the final slide. So if you need anything more, just comment and let us know. And don't forget to like, share, and subscribe. All right, that's it. Bye.